Yo, quantum mechanics starts out with something known as the Lagrange multiplier. You can read more in my flyer. Or actually it doesn't, that was a joke. What quantum mechanics is all about is particles much smaller than those contained in smoke. I'm of course talking about electrons, including their orbital-like movement. Like it was sent from above. An orbital is really a chance where you can calculate where the electrons dance. Now everything other than hydrogen is just a bit complicated for the general equation. That's why it is such a hated subject. But quantum mechanics is actually dealing with things in the magnitude of the Planck constant, meaning that it's much smaller than an elephant. It actually deals with atomic and subatomic wave functions, including the chemical junctions that atoms make with each other. Yes, even with our brother, meaning the same type of atom. In fact, based on quantum mechanics we can calculate how chemical substance reacts to light, and yes, it's a real bitch fight. For an example, chlorine simple bond breaks if the photon has enough energy. That is the reason why photons are working with us humans in synergy. The chemical bond make atoms stick like glue, but what you can do? Manipulation of the wave function usually requires the bracket notation, so if you can overcome the temptation, you are in for an easy win. Now way quantum mechanics is all about, and I ain't afraid to spit it out loud. It's about calculating the position, momentum and other properties of particles. It's actually just like the interpiston. The start of quantum mechanics came about with the calculation of energy of particles of light. Energy equals frequency times the Planck constant, meaning that the higher the frequency, the higher the sequency. Yes, I know that sequency isn't a real word, but try rhyming like a Danish nerd. But what I was trying to say was the higher the frequency, the higher the energy, meaning that the lower the wavelength, the higher the strength. The next calculation causes a lot of frustration, because it at first sounds like a tough nut to crack, but please wait with the smack. Cause once you know the factors, it gets easy like raptors. This formulation shows that a system's atom state changes with time. And that is why my next rhyme will show you. But let's get started. It begins with an imaginary unit, also called a complex number, which sorta looks like a cucumber. Next it's the partial derivative of something, divided by the partial derivative of the time. Doesn't this make you feel like you're one person with a life? But first the unit mentioned before is multiplied with the reduced Planck constant. Next we multiply with the wave function. How many times must I say wave function during this song? Oops, a hot girl on YouTube just lost her thong. Which equals the Hamilton operator, which by the way isn't an alligator, times the wave function again. Damn it, you are driving me insane, my friend. When you're applying this calculation, and in the atom it is important that you understand the Coulomb interaction, which basically just describes the attraction between a negative charge and a positive charge, and I can tell you that it's large. Actually it's much larger than the gravitational constant, and that is not blatant. Not a real word again, huh? Well, the reason for this is that it's virtually impossible to rhyme with constant. But of course there is a lot of other equations describing a wide variety of situations.
What's next? You decide, just leave a comment.